Good afternoon. Devigala ma'am.
Very good afternoon, ma'am.
Good afternoon, ma'am. We can start, ma'am. If all participants join, means we can start. Shall we start?
Yeah,
Or shall we wait?
actually, they
Yeah.
are joining. I think
Yeah, we'll wait. No problem. Yeah, we'll
one
wait.
or 2 minutes. Let us see for 1 or 2 minutes, ma'am.
Okay, no problem.
Okay, ma'am. Thank you, ma'am. Your signal is okay, no, ma'am?
Yeah, now my side is okay. Clear.
Okay, thank you, ma'am.
Thank you.
Thank you so much. A very good afternoon to one and all present here. So, welcome, Dr. Shima, and welcome, my dear participants. So, on successfully, we have come over here for the 4th day of faculty development program. So today we are going to have a speech on a simple and robust framework for boosting image encryption performance using artificial neural network. So we welcome Dr. Shima ma'am to take over the session. Ma'am? Yeah, screen is displayed, ma'am. Ma'am, please unmute your audio, ma'am.
Okay, sir. Is it visible, ma'am? My screen.
Yeah, screen is visible. Your audio is also good, ma'am.
Okay. Thank you. Good afternoon. Yeah, good afternoon, one and all present here. So, welcome to all for the 4th day of our FDP. So, as ma'am has given the title, so today I'll be giving a small, like how I just like to share my knowledge. Topic a small and robust framework for the boosting image and pressure performance using artificial neural network. Today I'll be discussing about introduction and literature. Literature I just will skip because I don't want to take more time in literature survey and conclusion and the works related to this topic. So, in this method, Okay. So today, last day, I think I have talked about SVM support. Okay, vector machine. Before I have talked about multiple image encryption algorithm, and first day we are talking about ECC, right? So today we start with artificial neural network or AI. Okay. So this work mainly introduce neural network based encryption scheme. Okay, why I'm using neural because I want to strengthen my encryption performance of my image or a data. Okay, which is capable for dynamic security operation. And here also, now, as I told in all my work, I'm using confusion and diffusion. Here I'm using permutation and bittexor. Permutation is confusion, and as well as bittexor means it is diffusion, confusion, diffusion of the images. Okay, for secure transmission. So both I'm using here, and in even all my work, you have seen like I'm doing the analysis also. The analysis is both we have to do the statistical as well as the differential analysis. So NPCR, UACI, entropy. Without this, we can't confirm our algorithm is good. So this is a basic thing. Evaluation metrics we have to do it for
Cut
the
that.
so
Okay.
NPCR, UACI, entropy to prove the high security level and high sensitivity is used to adopt my network security and secure communication. And finally, here I just like to confirm compared to other encryption technology, encryption using ANN, okay, is giving less number of time and it is faster than 20% faster than the existing approach. Devikala ma'am, Devikala ma'am, any bottom disturbances from other end? Can you ask faculty to mute? Thank you. So here we are using NN method, neural network based encryption, and here we are using all the evaluation metrics like NPCR, UACA. Okay, and finally, this proposed method, I would like to share. Like here, we are getting a significant reduction in encryption time. Okay, so it is more faster, 10 to 50% faster than the existing approach. So this is a proposed neural network in image and image security. We can say this block diagram tells us how what is the basic things I have followed in this proposed method. So as we know, input is my image. Okay, image I have taken. I have given my input for neural network or training because neural network we can give n number of inputs. It can be trained, okay, and we can test it and we can check whether our output, okay, whether the predicted output is correct with the trained output, right? We can check the output with the actual output, predicted output and actual output is correct or not. That's what main use of neural network, right? So I have used a random number for training my neural network. That is my secret key, one of the secret key. Random number I generated. Okay, and this is sent through a secret channel. Okay, so in the receiver side, after that we have to use same random key to decrypt it, and you have to check the validation. Okay, and finally I have to check whether compare and check whether it is authenticated output or not. The output is authenticated or not. So this is the basic things normally we'll do in the neural network concept using image security. So training, testing, and validation is the basic thing every time we have to follow. So as I told in my work, I am doing training. Okay, training with only one image. That is in training is with respect to the array of pixel as well as with the encrypted image. Okay, and output is another set of values which can be used for doing the next level of encryption. So after training, the values what I got from the neural network is my another secret data. Okay, that can be used for next level of encryption. So this is what my plans. I'm not using 1,000 or 800 of bulk of images for training and do any comparison or something like that. So my work is very simple. I'm training, but not with multiple images, only with encrypted image and an array of pixel. So in this, as I told, input data, input image, okay, with the help of external key, I'm generating an ANN model for encryption. Okay, so ANN model to generate, we need some kernel values and bias initial values. Okay, So as in yesterday I told weight and bias. Similarly here also we need a weight and bias here, and encrypted image will be getting finally. Okay, that is gone under different performance analysis. So input image. After that, after getting encrypted image, we have to do the performance analysis of both input image as well as encrypted image. So which will give the final output. So performance analysis with respect to input only we are doing always. So that is the final output. So here, as I told, we are having level 1 and level 2 encryption. So in all my method, I'm using 2 types of encryptions to prove that our algorithm is more strong against attack. Okay. So first, our aim is to take the input image. We have to pre-process, means pre-processing in the sense we have to resize. For example, every time image won't be symmetric. It may be asymmetric also. So better if you do symmetric, convert it to resizing to symmetric means we can avoid more errors while doing the MATLAB coding. So pre-processing is done. And if it is color image, I have converted to gray because grayscale image, grayscale image normally we'll prefer while doing any encryption, decryption, and later we can convert back to the RGB also. So in first level of encryption, I need a key. So key generated with respect to the height and width of the input image in first level. Then second level, okay, followed by second level of encryption, and finally I'm getting the encrypted image here. So this is my conventional method. So like SVM method yesterday we have discussed. Now the training side, as I told, this encrypted image, okay, is my target vector, and input vector I'm giving. Input vector is what? 0 to 55 array of pixels. Okay, the method is same, but here I'm using ANN instead of SVM. And input vector is 0 to 55 array of pixels. And I need an external key to control my ANN training model for encryptions. Okay, so this will generate a ANN model for encryption with the help of kernel values and bias initial values. This is the proposed flow of my ANN model for encryption. Okay, so it's very simple. Once again, in more graphically I have put so that it will be easy to understand. 0 to 55 array of pixels I have to prepare. That is gone under conventional encryption method. Conventional encryption method means by using DNA. Okay, DNA, that diffusion, confusion, that same pattern only. Okay, then because that method is simple and even we are getting a better results. So encrypted data. Now to get an ANN trained model, input is required, target required. What is my input? Input is 0 to 55 array of pixels, and my target is my encrypted data. So both are given to my ANN model. Okay, with the help of weight and bias, I'm getting an ANN trained model. Like this is my proposed ANN model. Okay, this is what I designed for my work. This is my ANN model. So once training done, we will be getting an ANN model like this. So ANN trained model, how the mathematical what is the max behind this training? I'll just explain, because yesterday Manigan sir was asking what is input, what is weight, bias, and all. So what is actually happening? These are the input, input to the neural network. So I have generated we can design any layer of ANN actually. That's in MATLAB we have the option to design we can design the input layers, output layers, in between how many required. Okay, so I have taken 0 to 255 array of elements as an input. Okay, and each input is multiplied by the bias, multiplied by the weight and added with the bias. That is shown here. Okay, so input image, that is 0 to 1 to 56 or 0 to 55 array of pixel. Okay, multiplied by the weight. Okay, weight, and that result is add with the bias vector. So that is the equation is x1 into w21 plus b1, like that. So x1, each and every node or in every input or node is multiplied by the weight and added with the bias, and that is given to the next level of the layer. So this is how this is done. So here I use an log sigmoid, okay, an activation function, and finally, and even linear also is an activation function. Activation function is mainly, what is the use of activation function is it will normalize your output. Mainly to normalize your output, we are using activation function. Okay, so in every neural network training, there will be an activation function which will give you a normalized data. Okay, so this is how I have done. Here I mentioned the size also, size of my input, size of my weight, okay, size of my bias. So if I do this this multiplication followed by additions, I'll be getting an output, and that is given to the activation function to give the normalized output. Then followed by again the result is again add multiply the next vector, then add with the bias. So this will be like this. It's a continuous process. Okay. So once I reach the end of my neural network, okay, I'll be getting a the final output that can be used for generating an ANN model. Okay, so activation function, and if in doubt anyone is having, you can ask me. I can tell there we have different types of activation functional neural network actually. So it mainly decides whether a neuron should be activated or not, or by calculating the weight sum and even this weight sum with the bias. Okay, so this is this we can see if you go for different layer of ANN also, for every stage by we need an activation output. Okay, activation function is required. Actually, it will decide whether the neuron input to the network is important or not to process the prediction, because it will predict the output, right? Whether it is required to consider whether we have to process the prediction using simple mathematical operation or not. Mainly, it decides whether neuron should be activated or not. Also, it will decide whether the neuron input to the network is important or not to the process of prediction using simple mathematical operations. Okay, so we have different types of activation function. We have ELU activation function, we have linear activation function, we have log sigmoid, we have tan. So I have taken here log sigmoid, okay, and linear activation function. So this is the ANN train model which I got after training. So input multiplied by weight, okay. Then yeah, I'm adding with the bias, then I'll get the output that is given to one activation function. Okay, it will normalize the output, okay, and you will be getting the that output is given to the next layer of ANN. So next weight multiplied again add with the bias, you will get output that is given to next activation. So like that, this will be keep on continuing. So I have taken here 256 cross 1 as an input. So as I told, we are using 10255 array of pixels. So the size of my output is 56 cross 1. Okay, so this is the equation behind it. H is equal to what is H is this output, tan sigmoid of, because sigmoid activation function I'm using, B1 plus weight into input, and Y, the final output Y is equal to pure linear of B2 plus W2 into H. Okay, so this is a like mathematical expression. Actually, it's a pure matrix multiplication only. So weight 0 0 1 0 multiply with the input, okay, with the bias, you will get outputs. This is how the calculus is doing. Okay, now, so as I told, we have conventional encryption flow followed by ANN encryption. So in conventional encryption, I have level 1 and level 2. Level 1 is, as I told, confusion. Just I'm doing generating a random number, okay, with the help of secret key, which will shuffle the pixel of my input image. So I'm doing permutation. Okay, randomly I'm permuting and I'm getting an input image like this. Okay, so I have plotted the histogram of both. So here you can see histogram of input image and permutation is not no difference, almost same, because that's why level 1 permutation or just shuffling of the pixel is not a good encryption method actually. So that's why I'm going for second level of encryption. Even though it looks different, the output and the input image looks different also. If you see the histogram, it doesn't show any significant difference. So we will go for better second level of encryption. Okay, second level of encryption, this encrypted image I've taken here. Okay, whose histogram I have shown again, same histogram only. Then I have undergone bit XOR operation. Okay, with the help of secret key. So bit XOR, each bit by bit it will be XORed, and finally I'm getting a good encrypted output whose histogram I'm getting a uniform response. Okay, this is my conventional encryption flow. Okay, and ANN encryption, once it is done, as I told, we have to go second level step is ANN encryption, right? So input image is given for ANN encryption, and I got an ANN train model like this after training. So that has to be given as an input, okay, to the ANN. And finally, what is actually happening here after encrypting, after training, ANN will be giving a set of values that is like how SVM have given. Okay, 0 to 55. For every location, it will give 111 value. That is taken as a new trained values, okay, and which can be used for replacing the pixel values of my input image. So here also I'm doing 1-to-1 mapping only. Each pixel, okay, for example, 0-1 means this location, particular, what to say, the pixel value is replaced by 48. And this particular pixel value is replaced by 0. So like that, each and every location pixel values are replaced by the new trained ANN trained values. And finally, you'll be getting an encrypted output with ANN. Okay, this is what the basic idea behind this. So ANN result also for the same whatever I have explained last presentation, the same image I have taken, because these all are the standard image which will get from SAPI database, which is having high good quality, high resolution image. So these images are taken as my input. Okay, and histogram is plotted here, and by using sorry, this ANN, by using AN, these are the result I got, and this is the histogram, and these are the correlation coefficient analysis around horizontal, vertical, and diagonal directions. Okay, similarly, the following three more images results you can see here. And if you go with the real-time images, I have taken that map image. Okay, when cancer detected patient image, medical image, one check have taken, check image, one coin image have taken. Okay, this all things also have done the same algorithm. I'm getting a better result like this. And even the same, the real-time images is correlation coefficient, UACA, NPCR, entropy is calculated. Here you can see that time taken is very less actually. Very less time has taken here. Very fraction of second I'm getting the result for encryption. So vertical diagonal and horizontal, the correlation value you can see here, it's less than. This is for the encrypted image, say less than 0. And UACI 31 should be around 32, 33. Okay, some images I'm not getting exactly 33. NPCR I'm getting a good result, 99, near 99. Entropy should be 8. That also I got 8 value. And averages have taken. So average is okay, far better. Only USCI, because of real-time images, this I'm not getting exact 33. Okay, nearby I'm getting 32 I got. And here are the other different images, like the database which I have download from the SAP. Okay, so this for all these images I have calculated the horizontal, vertical, diagonal, and time also I mentioned here. Encryption time taken in second only. And yeah, for the comparison, because in every work we have to compare with existing work, and we have to show that our proposed method is better, right? That is what a research means. So I have done that for a few, some 4 or 5 paper I have taken related to this work. And these are the NPCR, UACI, and the world coalition coefficient value of my proposed scheme. And yeah, key space analysis is very important, because every time that is a major thing, task we have to take care, like whether the key size is whether we can manage or not, that is it is tough to resist brute force attack or not. Okay, so here I have taken this other following key actually. So for input I have taken ABCD as for randomly taken ABCD as an external key, and the key size is mentioned here in byte. Okay, 2 byte, 2 byte, here 1 byte, 1 byte. So this all together it's coming 136. So 2 raised to 136 is my key space. But it is large enough to resist the brute force attack. As I told, 2 raised to 100 is the target, like it's a optimal value. So I'm getting more than 100. So I can say my my key space or my algorithm is enough for this very tough to resist against a brute force attack. So what I want to conclude in this work is, so here as our cipher image has very low neighboring pixel correlation, approximately it's having uniform. All the work was the same thing happened. Pixel correlation, if you see, it's low neighboring pixel correlation is very less in the case of image, the input image. And if you see the input image, it's highly correlated. That is why you're getting a straight line in correlation. In my graph, blue color is a straight line you can identify, and the red spot is a low correlation image of the encrypted image. Okay, and the results and security analysis show that our algorithm is good. So all the results we have seen now, and it is ability of resisting exhaustive attack, statistical attack, differential attack. So statistical attack, differential attack, all the parameters, evaluation parameters we have discussed now, NPCR, UACI, entropy. Yes, these all things comes under. And even SSIM I have not put. SSIM also I checked. I'm getting one only. Structural similarity index for a decrypted image and input image. I'm getting SSIM as one. And the main thing is regarding the key space. It is sensitive to plain image and encryption key and has have large key space. Key space is large because all the secret key, whatever I've used, I mentioned there, and the key space is more because it's not a one-time encryption. We are doing multiple type of encryption in each and every stage. Okay, so I had to count all the keys, but all the keys I'm using. Okay, so that's what we can prove our algorithm is strong against particular attack or not. And the time taken, I scheduled is more faster compared to DNA. So why I put DNA here? Because my next work or tomorrow I would like to share my encryption using DNN, deep neural network. Today I'm talking about ANN. So compared to DNN, here I got better result. That's why I mentioned here is giving 60% of faster encryption time, okay, than the DNN. So that we'll see tomorrow. That comparison, I'll show the comparison of all the three SVM, DNN, and ANN, and I have done an analysis on that. Because of this question will come definitely why the process is same. I use three different method or algorithm by using ANN, by using SVM, by using DNN, right? The process is same actually. You have conventional encryption method followed by you have decryption, so encryption by using SVM, ANN, and DNN. So method is same. So the thing is I have done the three. I just want to prove which is giving better results. So that analysis also have done that tomorrow we'll discuss which is better, giving better result. Okay. So the same work I have published in an LCVer, okay, LCVer journal, which is having good impact factor. So that's about today's thing. So I just want to show my result also, what I got. This is a code, okay, code for this ANN work. And I will run and show. Yeah. So this is yeah. So this is I'll just to show you my code how it is giving the better result. So input image. This is histogram. The input image. Okay. Then conventional method output I'll show. So conventional method means we are using what permutation followed by encryption, right? So that finally I'm getting a good result. Only permutation output means we are not getting proper output for histogram. So after doing bit XOR, we are getting good. Then ANN training. Yeah, have done for eight iteration, I guess. Epoch has again for around 8 iteration. 8 iteration are given. Okay, and this is the trained out model. Okay, so feed forward neural network model have used trained model and encryption using ANN. So this is the encryption using ANN which I got encrypted with ANN. And for the performance analysis, so encryption is happening within fraction of second. Right? You have observed. So time taken is very less here. So this is my vertical, horizontal, and diagonal analysis. So I'll just close it, everything. Yeah, you can see the performance analysis I have taken only 0.159 seconds only have taken for encryption. And correlation value is 0.003. Entropy I'm getting near to 8, and this is the correlation coefficient value. And key sensitivity I have checked, okay, but I have not mentioned the PPT. And PCR value I'm getting 99.33 and even 32.12 for USA. So that's about today's topic, and the encryption using ANN. So if you have any queries or any discussion, we can have now. Yes, sir or ma'am, any discussion is there? Shall we have a discussion regarding this topic or any doubt? If you want me to explain particular slide, let me know. Yeah, Devika ma'am.
Hello, ma'am.
Just can you check with ma'am audience whether anyone have to discuss with me?
Yeah, sure, ma'am. So very nice, ma'am. Thank you so much, ma'am. Really, we had a good session on ANN.
Yes.
And your results also proved very well.
Yes.
Dear participants, so if you have any questions, you can please raise on it. I think it's okay, ma'am.
Yeah, it's okay, no problem.
We can manage it. Thank you so much, ma'am, for your wonderful session.
Yeah, ma'am. Tomorrow,
So,
ma'am, 2 o'clock only we'll start. Tomorrow I can start.
Oh, yeah. Okay, ma'am. Okay.
Because of today's meeting. Yeah, no problem.
Yes, ma'am.
No, tomorrow shall we start at 2 o'clock only?
Yeah, tomorrow we'll start by 2 o'clock, ma'am.
Okay, okay.
Thank you, Dr. Shima, ma'am. And
Thank
dear
you,
participants, so successfully based on your timing also, it was a very good timing we had today.
Okay.
So participants are a little bit, only few members are there.
No, ma'am, I can understand. Lunch time, right?
Because, yes, ma'am. Okay, ma'am. Thank you so much.
Thank you.
So
Thank
we'll
you,
see in the tomorrow session. So dear participants, we can join tomorrow by 2 o'clock.
Okay, ma'am.
Thank you. Thank you.